All right, let's take a look at problem 6 from the exam. So solve for all possible roots of the following system of equations. And so we have a system of two nonlinear equations. Great. And then again, write a script or function to demonstrate your solution. This way I need just run your script or function to reproduce your results and confirm you are correct. My note is I was able to obtain two unique solutions. That is two unique xy pairs. Right, and so it's second order in x and y, so we would expect that to be the case. If you're using the random number generator, generate initial guesses. Please also record your solutions as a comment in your script. Okay, so that's if I just solve using multiple different initial guesses using my random number generator, it's record the two values of my comment. So let's do that and let's see what we can do. All right, so I have a system of equations. So I'm going to solve this using fsolve. And so I'm going to start with my error function. So my error function, just like f0, could have a single input or single output. The one thing I'm going to have to do is this top equation. So remember, both my error functions should evaluate to 0 when I find the xy pair that satisfies my system of equations. So I should rearrange this, bring the 2 over to the left-hand side, so that will be equal to 0 when I find an xy pair that satisfies my system of equations. Okay, so I'm going to create my error function. So function res is equal to, and this is what, problem 7 or problem 6, error prob 6. Okay, and so this can have just a single input, x. Okay, so I'm going to start by unpacking. And so I'll call the first element x, and I'll call the second element y. Okay. The significance of unpacking is it just better helps me keep track of my variables, specifying initial guesses, tracking my solutions, and things of that nature. So the order in which I unpack is going to be the order of x and y, which I'm solving for when my solution's returned. Okay, so now my system of equations. So now my error functions. Okay, and so we could just write directly to it. So I'll say res1, or I could write two separate and pack. Doesn't matter. Okay, so another reason for unpacking is now I can type this in a more similar form of my actual expression that I'm trying to solve. Okay, so there's my -2 so that it's equal to 0. Okay. I'm going to vectorize just for good measure. Okay, cool. Res2. Okay, so that's x times y plus x minus 1 squared. I'm going to vectorize for good measure. Okay. Bam. Okay, and that's that. So I have my error function. Okay, cool. And then I'm going to write a script to solve. So I'm going to put in a script because I'm assuming that that's what most of you would do. And so I'm going to solve with a random initial guess. Okay, so let me solve and let me say x. So x will be a vector where the first element is my solution for x and the second element is my solution for y. Okay, so let's test this out. So I'll just say x is equal to fsolve. Okay, and that's going to be my error function's error prob 6. Okay, and then I need two initial guesses. Right, first initial guess is for x and y. Right, the order in which I'm unpacking. And so if I have a physical problem, usually I can come up with some physically realistic initial guesses. For a problem like this, I'll just use the random number generator, and let's do random numbers between, say, -5 and 5. So I'm going to do rand, okay, 1 comma 2. So that's going to generate random numbers between 0 and 1. Okay. And what am I going to do? So I am going to multiply this by 10. So now that's between 0 and 10. And I'll subtract 5. So it's between -5 and 5. So I'll say as my initial guess, I will use random numbers between -5 and 5. Okay, so rand will generate random numbers between 0 and 1. I multiply by 10, so now that's between 0 and 10. And then I subtract 5, so that changes my range to -5 to 5. Okay, and let's just kind of test this. I'll call this problem 6 solve. Okay, so if I run it, okay, here's, oh, and so it looks like I didn't suppress my output up here. So let me suppress that. Okay, but I did get 1, right? So, oh, no solution found. Okay, let's try again. So if I run it, oop, I want to run this. So if I run it, no solution found. Okay, let me try my changing my initial guess, maybe. Let me round to integers, see what happens there. Okay, so if I round, okay, now magically I get equation solved, so it's sensitive to my initial guess. Okay, so here's my first solution, right? So I'm just going to record it here. So unique solution 1, okay, it's going to be this. Okay, so in the problem statement it said to record my solutions there, and I was told I found 2. Okay, so the second time I ran it I got the same. Okay, this says no solution found though, so that's not reliable. So it looks like equation solved here, right? So this is 1 and 0. So we call this unique solution 2. And the better way to do that, so let me do this, right? And this would be what I would expect for your solution. And then let's see if we can't kind of automate this just for good measure. Okay, 1, 0. No solution, so that's not reliable. No solution. Equation solved. This is my first solution though. Okay, no solution found. No solution found. Equation solved. 1 and 0 again. Okay, so it looks like if I keep solving, all right, when it does solve, I get back to the same solution. Okay, so this is what I would expect from your solution. Right, it is challenging or tricky, right, in terms of the results being sensitive to that initial guess. But here you go. I've recorded my 2 solutions here. Okay, so in the context of the solution, that's fine. I'm going to try and automate this and see if we can do a little better job at how we would automate in terms of running this multiple times and pulling off good roots. Okay, but this is fine for the solution. All right, so what I would try and do, or what I would do to update this, and let me save another copy of this. I'm going to call this problem 6 solve, I don't know, super. All right, here's my super version. Okay, and so I'm going to solve with a random guess. So x. Okay, cool. So I'll keep this. All right, so I'm going to do this. Okay, but what I want to do is I want to run multiple times. So I'm going to run 100 times. Okay, so I'm going to set up a for I equals 1 colon 100. Okay, now remember I don't actually have to do anything with the index variable. I could use it as a counter. Okay, all right. So now what am I going to do to automate this? We saw that several of the solutions that I had, right, were bad, right, in terms of, equation not, or no solution found. Okay, so what I'm going to do is I'm also going to have it return this flag variable. Okay, so I'm going to get my vector of my solutions, and then I'm going to create a flag. Okay, cool. Well, let me set something up so we actually collect these. Okay. So if I'm going to run 100 times, okay, let me create X. So I'll have variables to store solution and flag. So X is going to be equal to, I'll do zeros. Okay. Now, number of rows, I'll make that I. Number of columns, I'll do 2. All right, since I'm going to get 2 solutions from each. Okay, then flag will just be zeros. Oh, not I. All right, 100. Zeros is going to be 1 row. We'll do 100 columns. Or I guess it doesn't really matter how I set it up. I can make it a column vector too. Right, it's all the same. Okay, it's just a vector. All right, so then I write to X. Okay, this is going to be row I, all columns. Okay, so I'm going to write 1 row at a time, and then this will actually be running to the ith element of that flag vector. Okay, great. Okay, now filter the solutions. Okay, so what I will use the flag variable for is I only want the elements of X for which the corresponding flag value is equal to 1. Right? If it's 1, it's reliable. And so, let's create a logical vector. So I'm going to create a f. I'll call it like flag 1, and I'm just going to check if flag, I'm going to take it in multiple steps, is equal 1. Okay, so now I'm going to get a logical vector. Okay, and so I'll say x, 1, like my good x's. What I want is, hopefully this works. I want x. Okay, what rows do I want? Okay, I'm going to use my logical vector to filter out my rows, all columns. Hopefully that works. Okay, cool. And then to make sense of it, let's see, can I sort? Okay. So let me do help, and let me just start typing sort. Sorted rows. Okay, so what's sort versus sort rows? So sort is sort in ascending or descending order. For matrices, sorts each column of A in ascending or descending order. I don't think that's what we want. So, alright, because it'll take each column independently and sort them. Sort row sorts the rows of a matrix in ascending order as a group. Alright, that's what we want because they're a pair of solutions. And so I want, let me sort it. I'm going to do x1 is going to do sort rows of x1. Okay, just so I then sort it. And I'll call it x1 final. Okay, cool. All right, and I'll display that one. Okay, so let's see if I run this now. Okay, I didn't suppress something, so let me suppress that output. Let me suppress this output. I don't want to see all the output. Okay, cool. Let me suppress this, and I'll just open it up in the editor. Okay, so now if I run, okay, that's great. I'm going to open up this x1 final. Okay, so it looks like I had 64 legitimate solutions. Okay, first solution is this. Okay, then it looks like I have my 1, 0, where these, I'm guessing, are going to be extremely close to 0, right? It's a numerical solution. So it looks like 1, 0, and then this are my 2 unique solutions. Okay, cool. And I could even try changing my initial guess. So maybe I go from negative 10 to 10. Okay, and I could rerun this. Okay, x1 final. Now I get 52 unique solutions this run. Okay, but it looks like it's the same grouping. Okay, cool. So the solution I had before is fine, right? Here's me trying to automate the process, right? And that's also fine. Okay, cool. But when I try and automate it, this flag is important. Okay, so if I do help fsolve, right, the flag is important just so I can use that to only look at the solutions that I think are or will be legitimate, right? So here we go. So remember, I can get 3 output variables. So x is my solution. Fval should be the value of my function at, so if I plug in x into my error function, right, fval is what I would get, so the value of my error functions with that solution that it produces. Then here's exit flag. All right, and so exit flag can correspond to all of these. All right, so one being that fsolve converged on a root. Okay, cool. And so that's what I used here to automate it, but the other solution would have been perfectly fine. Okay, hope that helps. We'll solve the next problem next.